Everybody, welcome to VCF West. Thank you for coming. Today we have an amazing engineer who was there in the before times. Joe Decuir, everybody, big round of applause.
I've been accused unjustifiably for having invented some of this stuff. What I would always say is I contributed to these things, and I was lucky enough to contribute to these things. I tell a lot of my students that an engineering curse is that you'll have to work on stuff that doesn't ship and doesn't change the world. And I've been lucky enough to work on a lot of things that shipped and, in some cases, changed the world. I worked on medical electronics before I went to Atari. I got the Atari job through my network. I worked on video games and personal computers. I was elevated to IEEE Fellow a few years back for contributions to video games and personal computer graphics. And that's what this talk is about. But while I was there, I discovered the internet and went off to contribute to dial-up networking, paving the internet, operating systems. While at Microsoft, I started working on USB, and then I started working on Bluetooth. And I did that until 2015, and took some time off and became a professor. So that's where I've been so far, and I'm not done. In any case, I'm here to hang out at NerdFest Central. Yay! So, why are you here? Of course! Proud of it, too. I got here for designing those three machines. If you find me on Wikipedia, it lists those three machines, and that's what I'm guilty of. Or I'm one of the perps. Okay, so I've been corresponding a lot with the organizers because I've done a pretty big presentation, and it's technical, and they said, yeah, but people want to hear stories. So what I'm planning to do today is I sat here with Bill Hurd, and I said, here's 6 or 7 stories that I should tell, and I'll punctuate it with the technical detail. So I'm assuming that VCF will post the slides. They might even record these things on YouTube. This has happened before. And if somebody wants to learn more, they can watch them again. And for example, the Amiga demo, which is referenced late in it, you can watch it again. And that's fine. But he says, stories they want, stories you'll get. Okay, so, and this will end with some stuff which I'm not going to talk a lot about here, but these old machines you can still get the native hardware, you can get modern emulations of the hardware, and you can run them on simulators. There's still stuff happening in these spaces now. All right? So, and why are you today? Well, you're probably fans of these old things. And you maybe even still use them, not just use them to occupy space in your garage, right? Some people are still writing new applications. There's a group led by Tom Cherryholmes that ported network applications to a bunch of these old machines, and he discovered we need network adapters. So he's now building these devices called FujiNets and added networking to C64s and Apple IIs and Atari PCSs and Adamses and bunches of old things that are too old and slow to run network stuff themselves, so he puts it all into this microcontroller. There are still people writing new games for these things now. There's an organization called Atari Age, and they still have NerdFest, and they're still doing new stuff. So this is still going on. Now, my agenda for today, stories interrupted by technical detail. How I got hired at Atari, which was amusing, an epiphany that I had when I realized Atari didn't have a roadmap and it needed one. I went to the San Antonio Sears store and Black Friday of 1977. That was an eye-opener. I'm going to talk a little bit about inventing a serial bus. As the phrase goes, necessity is the mother of invention. We'll talk about that. Proximity to Atari coin-op developers. That's why these things were games. I discovered the Minitel and then later left Atari to go work on paving it. I got to work on the first GPU with my buddy here, and I recorded some of the results of using that GPU from a 1985 machine. So this is a preview. If you're not interested, walk away, or if you want one in particular, tell me now so I know where to concentrate. Any suggestions? You want to hear them all? That means I need to talk fast enough to get them all in. That's fine. Okay, how I got here. Okay, so the first version of this talk I gave at the Living Computer Museum, which is now defunct, in the Seattle area. And in that place, instead of the stuff just sitting on shelves, as it is here, all three of these machines are on shelves here in this museum. But they're all working. And so I was standing in front of an audience, and the Atari 400 was right there. They could turn and punch on it if they wanted to. They could walk around the corner, and here's this guy. They can walk around the other corner, and here it was. They're all lit. Unfortunately, Paul Allen died, and they've closed that down. And, you know, some friends of mine and I would like to reconstitute it, but I'm not quite sure how we're going to do that. Now, first video games. These are animation machines, right? So I actually got a chance to meet Ralph Baer. And he patented video games the year I got out of high school, 1968, right? And he had built this device with a couple of rectangular paddle-like things knocking around this rectangular ball. He had controls that moved him in 2 axes on each side. And he didn't know what to do with it because he was working for a defense contractor called Saunders Associates. And finally, they licensed his design to a defunct American consumer electronics company called Magnavox. And they built this thing called the Odyssey, and they demonstrated it in the Santa Clara Valley in 1972. And by the way, his lab, I got to go down there on a pilgrimage the year before he died, and they have taken his lab apart, and it's been reassembled in the Smithsonian Museum of History and Industry. So it is permanently enshrined in our nation's capital. So let's see, I want this. Okay. So Bushnell saw this demo, and he went home and told his buddy, Al Alcorn, good concept, terrible implementation. Needs color, needs sound, needs a score. That became Pong. Pong was a big hit. Al Alcorn can tell that story tomorrow. They were pioneering the coin-op or arcade versions of these games as opposed to a home thing like the Magnavox Odyssey. So they were doing well, and they made more complicated games like Tank and Breakout and so on. And then they had a third hit. They did a random logic implementation of a chip that played Pong at home. So far, so good. This is 1975. Meantime, I'm working in the medical electronics industry, and my company's running out of money, and so I lose my job. I'm given 2 months' notice to find another job. I've been studying microprocessors on my own dime, and I went to the Westcon show and bought a 6502 and the manuals on the same day that Wozniak bought his, and the same day that the Atari people bought theirs. I didn't know this. So I give a talk at a conference on medical electronics, and I come home and discover I'm out of work, and I go to this show here, and I start looking for a job. And through my network, I interviewed with Ron Milner, who was one of the people who conceived of this system. And they'd been thinking, are we going to build more random logic games like Pong? Or are we going to build microprocessor-based things, which is Steve Mayer's contribution? And so I interviewed at Atari, and I had 3 things going for me, it turns out. One of them was that I was already fluent, at least enough to be dangerous, in software and in hardware. And I had been studying the microprocessors they had chosen, and I didn't know that. So I aced the technical interview. And then they walked me through the lobby at Atari in Los Gatos, and the interviewer said, "You want to play a game?" And I look around this room, and I panicked for a moment. I thought, oh, shit, I'm going to fail here. But I recognized Tank. And I had played Tank once that summer with my youngest brother, Bob. At the time, I was 24, he was 12. And we wasted a bunch of quarters playing Tank. He had better reflexes than me, so he beat me. But I was at least familiar with the game, so I walk over and I look at the Tank game. You want to play some Tank? Yeah. Played 3 games with the guy, and I won one of the 3 games. I was hired on the spot. Except for the births of my children, that was the luckiest day of my life. So I got the job, and my first job was then to run up to Nevada City, California, working for the people at Cyan, and get it all to work. So this is the prototype, which is exhibited downstairs. It was a conceptual prototype. You build something that proves that the concepts will work, and then you go back and rearrange everything. Now, one of the reasons I got hired is I was young, single. I was willing to move from San Francisco to Nevada City, and then from Nevada City back down to Los Gatos, because the people at Cyan had learned that if they sent a design down to Los Gatos without a person in accompanying it, it died. But if they sent it down championed by somebody, it would get built. And I was that person. In fact, I was up there the day that we introduced it to Bushnell and Alcorn. And Bushnell, well, I won't say what Bushnell did, but it was not printable. So anyway, I got to go do this stuff. And then there's a book, there's a cartoon guide to video games, and this is an illustration from that book. So I got to work with Jay. And I chose the job specifically. I had found 2 jobs. By cold calling, I'd found a job doing medical electronics in Orange County, California, 2 attractions of Southern California. The surface really good, and it's driving range from my parents. Cool. But I made a crucial decision that I wanted to learn large-scale integrated circuit design, and I chose a mentor who was going to teach me how to do it. So a little bit technical is, so I see, push that button. Okay. It was, as Steve Mayer would put it, a frugal design. Everything else that had been made before or after has a memory, piece of memory that's 2-dimensional. It's either a bit map or a character map. This machine had a line buffer because memory was too expensive. Does anybody have an idea how much RAM was in this system? So I see some hands. Yeah? That's too much. 128 bytes, an eighth of a K, right? And that's because most technology for those Kim 1s, they'd put a couple of 6530s in the design, and a 6530 had 16 I/O ports, a timer, 64 bytes of RAM, and 1K of ROM. And so we at Atari said, well, we're going to make the ROM separate, so can you double the size of the RAM? And they said, sure. So they made the 6532, which is 128 bytes of RAM, which we put into zero page, so it was easy, right? So True story. Why 6502 besides I had one? The 8080 was introduced by Intel in late 1974, and it cost $100 in onesies. The 6800 was introduced by Motorola in response. Unfortunately, it was built with enhancement-only NMOS, so it was physically slower. It was architecturally okay, but it was slower, so it was too slow to do the job. But Chuck Peddle left Motorola and went off and joined a team that built the 6502. They built it with an enhanced depletion load NMOS, so it was faster physically, and they architecturally made it faster. It could do address arithmetic on the fly. It could, you could say, load some from memory from a 0-page pointer added to the X register or to the Y register. And it can do all that address arithmetic in 5 memory cycles. Whereas to do the similar things with an 8080 was at least twice as long. Which means it was fast enough so that when you were displaying stuff, you could look up in memory and figure out some new bits to throw into the hardware, and then in the horizontal blank time, throw them into the hardware, and you wouldn't see glitches. So you could build a line-oriented thing, not a frame-oriented thing. Make sense? Right? So this here is a display that I drew from illustrating how the 2600 works. Obviously, we don't have a lot of resolution, but Atari was an entertainment company, not a chip company. In contrast, there was Fairchild a year before came out with a cartridge-based game system called the Channel F. Jerry Lawson, great man, I wish I knew him personally, did a nice job on it, but he was working for a chip company trying to sell chips. And we were an entertainment company that understood electronics. So we knew that people put their attention on your avatars of you and your opponent, and you don't spend a lot of brain cells or concentration on the background. So we had relatively low resolution background and relatively high resolution avatars. And that seemed to work. Atari had already learned this in the arcades, and what we were doing was simply bringing it home. So it would spend a whole lot of time just driving the hardware down the screen, and then during vertical retrace, it would think, oh, read the collisions, read joystick controls, figure out where things were going to be, and then display them again. That's all it did. No interrupts. Not even non-maskable ones. So this is the layout of the system. Here's this 128-byte RAM I/O timer. Here's this custom chip that we built that does video and audio. Here's the cutoff CPU. Here's our program ROM, which is 2,000 bytes or 4,000 bytes. Because that's what we could afford at that time in history. And you're thinking, how much did this thing cost? So we shipped this in 1977. Our bill of materials was estimated about $65. So the marketing people are thinking we can sell it 3-to-1. Our suggested retail was about $200. So we're trying very hard to squeeze it into what people could afford at the time. At that time in history, 1977, you could buy a new car for $2,500. And you could buy a house for $25,000. Can you imagine? Not anymore. So we're trying to squeeze it in at that time, which leads me to one of my epiphanies. So I'm thinking, what if the marketing people are wrong? What if we sell a lot of stuff and people buy more than 2 or 3 cartridges a piece? That means they're going to have cartridge collections. we need a pathway, a roadmap, if you will, so that people can reuse their old cartridge collections, right? And in a sense, we were telling everybody that whatever games they buy, they're going to have to buy them all over again with the next platform. I said it would cost us another $1 to buy a 40-pin CPU and a 30-pin cartridge connector so that we could migrate forward and build forward-compatible things that would play old cartridges. And the management said, it's already too late. We can't change now. But I had that concern. So I got to work on these things. That's the original 1977 Heavy Sixer, they call them. And I worked on the graphics engine for combat, and I wrote Video Olympics from scratch. Here we were. Our original mission was to do tank and Pong. And we built tank, and we got that out there, and we said, oh, by the way, somebody needs to do Pong. And nobody else stepped forward, so I said, yeah, I'll try. But I don't want to have to do more than 50 variations of games. And I made up, 8 major kinds of games with some variations of each. It turns out to be a popular party game because there's 4-player Pong and foosball and all these things. So it was good at parties. My children want to inherit those. They don't care about the computers, but they want those. Now, because the machine was much more successful than we expected, because being cheap, the vertical was in software, not in hardware. So the programmers were a lot smarter than we, the hardware people, could have imagined. And so people did astonishing things. I'm going to highlight a handful of the games that I think are the best original for this machine. Robinette Road Adventure. How many of you saw Ready Player One? Okay. Do you remember what the last challenge was? Really? The last challenge was to play this game, not to win the game, but to find Robinette's Easter egg. That's how you won the third challenge. So I think that's best original game. Very close. This is pretty amazing. And the action moves sideways. And another original game that I really admire was Carol Shaw's River Raid, where the whole world moves vertically. Anyway, I left out Yar's Revenge, but that's another story for another day. So what did we learn? We put the definition of the display in the hands of the programmers who were really smart. And our conclusion was that the second system should not, we could afford a bitmap or a character map now, but it had to be more than that. We had to allow the programmers to race the beam and do stuff down the screen that we couldn't imagine. We just knew that we had to put in a lot of hooks in the system so that that was possible. We realized that we had basically created a new art form. These were interactive cartoons. And so we thought we needed to move fast because we thought if we didn't obsolete our own design in 2 years, somebody else would. And they certainly tried. So given that, so I went on this pilgrimage. Yeah, I talked about needing a roadmap. The other thing is, we live in Mountain View, California. The San Antonio Shopping Center is nearby, so you would know this. And I was living at Ringstorf and Central Expressway when I was doing this work. So I went to the Sears store, and they had a Sears 27-inch TV, CRT, of course, because there were no flat panels. And the game was sitting there, and it was screwed down. And somebody had put in a screw into the cartridge slot so nobody could steal the cartridge. and the game controllers were nailed down, and there was a cloud of children around this machine. People would come, and this was the day after Thanksgiving, which they now call Black Friday. And people would come in, and their children would leap over to see what is it that they're all watching. And there's this cloud of children, they're taking their turn. Some of them were nicely mannered to take their turn, and they would learn the game by watching other people play, and then they would play, and then their parents would try to drag them off, and they would scream. But I watched this for 2 hours, and I was just like, oh my God, what have we done? That's why I thought we needed a roadmap, because if it was as successful as I thought, it's going to do well. So I got lucky. How many of you have ever read a book called Soul of a New Machine? Many of you, good. It's set, Tracy Kidder is a brilliant writer, and a lot of the people who worked on the Data General, they worked on the Eclipse, so some of them got to move on and work on the Eagle, the 32-bitter. So they get to play pinball. If you do a good job, you get to do it again. And I got to do it again, right? So we got a bigger team. We got to advance our technology. We went from 10 micron to, 5 or 6 micron. We had a hard decision. Is the next machine a better game console? Is it a personal computer, or is it both? To make a long story short, we ended up using the same chipset packaged differently. From a programmer standpoint, they're identical, which is good, because that means your games work. And one of the chip designers, Doug Neubauer, his chip worked the first time, so he got bored, and he's really a smart guy. So he wrote the best original game for it, Star Raiders. And Star Raiders blew the doors off of Atari management. And I said, oh my God, the game machine shouldn't have a keyboard that's an add-on. It should be included in some way. So they decided that even the oldest machine had to have something that could play Star Raiders because it needed a keyboard. So that's where the designers got to influence what got shipped. Now, for a better game player, we obviously now had memory mapped video, but we could make the bit maps 1-bit or 2-bit steep. If they're 2-bit steep, that means they point to 4 different palette registers. Each palette register has 4 bits to choose the color in a color wheel and 4 bits to choose the luminance. So we can have at least a 4-color display. Monochrome is obviously just 2 colors, but we could set those separately. And we built character modes. We're stuck with broadcast TVs, which have a limited bandwidth, but you don't have to buy a separate monitor for them. And we had the insight, if we're grabbing 8 bits at a time, to choose a monochrome character with an 8x8 or an 8x10 array, we could group those in pairs, and we could build multicolored characters where the first 2 bits choose a color, the next 2 bits choose a color, the next 2 bits choose a color, next 2 bits choose a color. So we could build multicolored characters and reuse them, which Nintendo used extensively later in the NES. We provided for horizontal and vertical scrolling. Why? We were in the same building with CoinOp, and CoinOp was doing all kinds of really amazing things, and we thought, well, if we're trying to bring the CoinOp stuff to the home markets, we need to follow what they're doing, and guys like Mike Alba was a source of inspiration. And to allow the programmers to mess with it on the fly, we said, oh, okay, we're not fixing the display. So we have a display list. So the Antic chip is a crude video processor. And it has an instruction for delays. It has instructions to choose either bitmaps or color maps. It can have horizontal or vertical scroller turned on line at a time, interrupts line at a time. So the programmers get to program a separate, simpler system that formats the display. So I keep missing this. All right, so yes, we were in the same building. We had lunch together. We played softball together. In fact, we played music together. This is me. So that's what Star Raiders look like. Flying through space, shooting beer cans, but they're fast-moving beer cans. And in this particular design, this is all bitmap, and this is a sprite moving object. This is separate moving objects. This is, you switched to a colored character display with a custom character set so they don't look like normal stuff. And some of these symbols mean your orientation and how far away your adversary is, et cetera, et cetera. So that's what Neubauer did. And then, obviously, we wanted to be able to port what they were doing in arcades. So, you know, this was an easy port with this design, and nothing flickered. Thank you very much. This was an easy port. This was an easy port. This was interesting because what was going on in this game was a whole lot of stuff. And of course, this is a photograph because it was fast moving with my camera. But the array of aliens are dancing around. They are character map things, not moving object things, because there's so many of them on a line. But you can build a character that looks like one of those things, and you can make the whole lines horizontally scroll independent line by line with displayless interrupts. And then you can replace the image of one of them by a sprite, you know, with the same colors, and then have it peel off and come down and shoo at you and get knocked down, et cetera, et cetera. So this was a fairly straightforward arcade port. Now, for a personal computer, gee, we have to do some work too. We only had we didn't have enough bandwidth since we'd sentenced ourselves to using TVs that we can only get basically 40 characters all across the line. Anybody who's seen Apple IIs understands that, right? But we needed a keyboard. Obviously, you needed to enter characters. We need peripheral expansion for printers and communications, and let alone hard drives. We wanted slots. We desperately wanted slots. We really admired the work that we knew about on Apple II, not only because Wozniak had slots, but his operating system was smart enough to go to each card and look for the drivers and download them. So it really was plug and play. But we knew that since we were driving TVs, that we were subject to the FCC rules. We had a Faraday cage around all of our stuff to hit the minus 60 dBm per megahertz. I know that sounds like magic, but that's really tiny. And Apple didn't yet have to deal with that. So what are we going to have to do? So the necessity was we have to do a serial bus. So we made up a US serial bus. I've seen people on the web claiming that I invented USB, and that's completely inaccurate. I contributed to USB like I contributed to a lot of things. The most important thing, where is my pointer? Okay, right. So this is some of the points. We shipped a serial bus in 1979. Commodore made a different usable serial bus by taking IEEE 488 standard, which is designed for instrument control, and serializing it. Works. But in the 1990s, I'm working for Microsoft, and I'm working part of the USB Implementers Forum, and the patent trolls come out and say, "You owe us a whole bunch of money." And we said, no. There's prior art from Atari and all of their customers. There's prior art from Commodore and all their customers that antedates their patent filings. Go away. I like unemploying the lawyers. As Michael will say, avoid litigation. I agree. So here's what a system might look like, and all those things are tied together with serial buses. Logically, here's what's going on in that same photograph. Here's what's going on inside this system. I don't want to spend a lot of time on this. You can come back and look at it later. What did we learn? As a game console, we were providing great self-development tools. You can write great retro video games for it, on it. We weren't afraid of Activision yet. They hadn't left. That's another story for another day. So Atari got afraid of them later. As a computer, we put a lot of cost into the system because of the serial bus. So, in 1979, a fully equipped Apple II cost less than a comparably equipped Atari machine because of the cost of the serial bus. For the plain machine alone, the 400 was nicer. People bought Atari 400s for $500 at the same time that an Apple II cost $1,200. If you're mom and dad and your kid wants a computer, you'd rather buy him an Atari 400 because it does speak BASIC, it plays great games, you don't have to buy a monitor for it, right? So I have a lot of friends who are in their 50s for whom that was their first computer. I'm glad they're at least happy about it. I was suggesting that we take advantage of the changed FCC rules in 1979, 1980, and build a simpler system, which they eventually did in 83, massive cost reductions. But Commodore was much more aggressive about it. They passed this. Atari sold about 6 million of the Atari 8-bit computers over time, and Apple II sold about 7 million of them over time, and Commodore sold 17 million Commodore 64 and related machines. So they won in the marketplace, especially in Europe. I wish we'd built an expansion slot version for it, but it was kind of too late. So we came out with this in 83, but it was kind of late. Last thing, my last engineering notebook from Atari, we conceived of the Amiga. And there's some Amiga fans in the room. Anyway, so that's where we left it. I left Atari to go work on the foundations of the internet. So here we can tell the story. So I'm an IEEE member. I'm a fellow. I read IEEE Spectrum, and in June of 1978, there was an issue that talked about the French Minitel system. How many of you have ever heard of the Minitel system before? Many hands. Good. The Minitel, in my opinion, was a French prototype for the internet. The French government had socialists running the country in the mid-70s, and they decided to be sort of technologically Japan. They wanted to be the technical leader in Europe. And so they decided to reinvent their phone system, and one of the things they did is they built an information system with very cheap video terminals with graphics characters, and they would give them away, if you're a French citizen, and the first information back end they built for that was the French phone books. They figured that the cost of 5 years of French phone books would equal the cost of one of those terminals. So they thought over a long time it would win, but they built a whole information system behind it. And as sort of a lark, they put in chat. How many of you use text messaging on your mobile phones? Chat is directly descended from Minitel chat, but it was such a huge hit in France, and the biggest application was cruising for dates. Duh, they're French after all. And people would run up 1,000-franc phone bills their first year of using the Minitel. It was just a huge, talk about killer applications, right? So I looked at that, and I had been thinking at Atari, is the future ROM-based cartridges? I don't really scale. And I read this, and my head exploded. I thought, okay, the future is computer-assisted communications. So I thought, all right, I'm going to stay at Atari long enough to get this thing successfully into production. I stuck around until the QC programs I'd written in production were coming up with yields in the low 90 percentiles. And I thought, yeah, I think I've done my job. And then I went up and started a company that was paving the internet. So that's the end of that distraction. That's why I moved out of the games market, at least for a while. How are we doing for time? We're doing okay. What? Okay. I got to do it again. There was some time off. I left Atari in '79. I started working with Jay Miner 3 years later. Jay Miner left Atari even earlier. Nolan Bushnell makes some marketing mistakes, and Warner offered him cement overshoes to leave, and they brought in Ray Kassar from the fabric business. Ray Kassar knew a lot of really good, important management things and marketing things, but he didn't understand technology to speak of. He said, we should sell our computers in designer colors so that women will buy them. And when he did so, most of the women who worked in engineering left within 2 months. And Jay left within a month. He went to go work to build a CMOS cardiac pacemaker. And then he finished that, he came back, he got bored, and he got recruited to be part of badge number 2 at what was called High Toro, which later became Amiga. So he took me out in the Delta on his boat, and he said, let's talk about the next machine, that one that we were thinking about here. Let's build it. So that's the first machine. I think that somebody was selling one of them out on the floor today, and that's one of the best illustrations that machine came up with. Now, concepts. The president of the company, Dave Morse, was a vice president of Tonka Toys, and he said what he wants to do is build a machine that can render cartoons in real time. We joked about Smurfs a lot. He wanted to accelerate bitmap manipulation in hardware. And he wanted to be able to synchronize with external video, do Genlock. We'll get to that later. As a computer, of course, now IBM has come out with their PC, and there's beginning to be a market for plain monitors. And if they're plain monitors, we don't have the bandwidth limits of regular TVs, so you can go 80 column or more, and in color. We could certainly afford enough memory to have a bitmapped Alto-like Window OS. I had actually seen the Alto demonstrated in early 1979. So I had a clue what the future would look like, and Steve Jobs had seen it, and a bunch of other people had also seen it. So we sort of knew where we wanted to go in terms of user interface. We thought we could afford, for a PC, at least 128K. This is in 1982. We wanted to build in a floppy disk, because, of course, we wanted other developers to be able to, instead of ROM-based things, they could have floppy disk-based games. And we wanted to expand to a hard disk. So I need one of these little clicker thingies. All right, now, Ron. So Ron was recruited out of Apple, and Ron had worked with the software people doing software-intensive, what they call bit blitting. And he'd learned about it. And so we teamed up to conceive of the hardware to do what was being done software elsewhere a lot faster. To create images, including blind draw and area fill, and then to manipulate images, to be able to take, here's an image, and I'm going to make a hole in it, and I'm going to take this thing and I'm going to paste it in. And do it all as fast as it takes to read and write the memory. So we basically designed the first graphics processing system, and I've unfortunately been dragged off to court a couple of times. I'm grateful that the patents have expired. Again, avoid litigation. But here's the simplified diagram of the inside of the thing. So there's a bunch of memory, there's a CPU, and there's 3 custom chips. Agnes address generation has over 24 DMA engines in it. I'll spare you the details. Daphne, or Denise, it got renamed, is the thing that collects and exports video information. And Portia or Paula, depending on which rendition you're talking about, is the one that does non-video I/O. So it could do DMA for audio, DMA for serial, DMA for the disk, and it didn't do DMA for the ports because they're happening too slowly. A separate discussion, which we could cover some other day, is the Amiga sound system is a 4-channel sampler. Didn't exist before, and people have made up informal standards for how to encode and decode information based on that design. But that's another story for another day. I still look forward in my copious free time to playing with the Amiga hardware that I now have. Let's see. So you can draw 2 lines, tell the hardware to draw a line through it, and it will. If you draw some more lines, you can say, the hardware will scan through it, and if it sees a 1, it'll start propagating the 1 until it sees another 1, and it'll stop propagating the 1. So you could draw lines and then say, fill it, and it'll fill it. So you can construct images that way with this machine. And again, it'll do it as fast as it can touch memory. And then, having done that, here's an illustration. Let's suppose the bit blitter was a 4-operand system. You could have 3 input operands and an output operand, and they could be the same place or somewhere else. And let's suppose you had a multicolored tank sprite image. Could be a Smurf for all I know, right? And then you've got the outline of the thing, and then you could have some randomly colored background. And you could feed these all into the blitter, and you could set up the blitter so that if the bit is set, you take the first image, and if the blitter bit is 0 for that location, you take the background image, and then you can splice that thing over the top of the other thing, or reverse it. But it could do that, again, as fast as it takes to read and write the memory, which was at least 10 times as fast as the software, which was the point. I'm looking for, right. We're not out of time yet. There's the mouse. Okay, so what I'm going to do is I'm going to close this, and I'm actually going to play this bit. Playing it here is better than playing it off the net. Now, I don't have sound. Oh, maybe I do. But what you're seeing, oh, I see. It's not displaying what I wanted to see. Okay, so hang on. Where is the mouse? It's not, it's, what? Oh man, this is not working. So I can't see any controls at all. All right, let's try this. Okay, so let's go back to the beginning. Okay, remember I showed you earlier this illustration that was color compressed? Really great, it's shadowing and everything. This is playing the game. And so this software obviously doesn't store all those images. It's actually constructing the image of the FA-18. It's constructing the aircraft carrier. It's constructing all the background. It's rotating it all. And this is real time. 1985. Jay Miner always used to say he liked flight simulators. The only game I play is Flight Simulator. Anyway, so here is the demo mode. And I shot this with the camera, which is why it's rotating like that. But I wanted you to get a sense about what this machine can do. We don't need to wait long enough for it to fly under the virtual Golden Gate Bridge, but that's what it does. Right now, it's flying around looking for an adversarial aircraft. It's going to find one, and it's going to shoot it down. And let's see. Like I say, this is a 7-minute long demo, and we're not out of time yet. Of course, it flattens things. You know, Marin County and San Francisco actually have a lot of up and down stuff, but it can't. There's our adversary. We're going to go fly after it, and we're going to close on it. Come on. I don't have a fast forward button. All right, but we're still chasing that adversary. It's running away, running away. How many G's are we pulling here? It doesn't tell us. It's certainly, we don't have haptic game controllers, so you can't feel. What? Oh, really? Nice. Anyway, we shot the thing down, and we're going to watch it crash into the ocean. There we are, and now we're so excited. And so that's the virtual Golden Gate Bridge that we're going to fly under. Remember, this is displaying on a non-interlaced color monitor that you could buy in the middle of the 80s. Yeah. So this is a machine that shipped in, what, 1985? And there we are. There's San Francisco on the right. The Computer History Museum is out of frame, but there we go. And it's computing all this stuff and animating as fast as it can with a 8 megahertz, 68K, and memory that's running about 4 mega samples per second. Anyway, here we are. We're flying under the Golden Gate Bridge. Right? Little shadow. Anyway, it's gonna land at Oakland. But and here's Alcatraz. There's downtown San Francisco, rendered with low precision, but it's rendered at all. So does anybody want to watch this go through the end, or shall I go back to stories? Stories, okay. So let's suspend this. And go back to the display. Where were we? Yeah. All right. Where do we go with this? Well, this last machine shipped, Ron and I were here for Amiga 30, which was 8 years ago this summer at this location. Where do we go now? Well, you can buy these things out on the floor, I suppose. You can do software emulation. There are FPGA re-implementations. There's new hardware development, and people are networking these things. So I'll talk about this, and we'll see where we wind up. So here's emulators. For the game machine, for the 8-bit emulators, I left off Altera, which is the one my students use now, and there's at least one emulator for the Amiga. A buddy of mine, Ed Fries, who wrote Halo for the original Atari Xbox, did a port, and he did this game for the 2600. The graphics are obviously very inferior, but thing is, he made it playable. It's actually entertaining. I'm not demonstrating that today, but it's true. So, a guy I met a few years back has developed a website that does game emulation, and it supports 2600. It supports the PCS now, experimentally. It supports the Nintendo NES. It supports arcade games on writing in Z80 assembler, and it supports arcade games written in FPGA. I invite you to entertain this. My students who are working on a capstone project are going to try to upload our code and demonstrate it on his PCS site. So you can still do this if you want. This is a comparison of a deceased friend of mine, Kurt Vendel, did the FPGA implementation that became the Flashback 2. And, so they shaped it to look kind of like the original console, but it's a lot lighter, and it has the great advantage of having composite video outs rather than RF outs on TVs that are illegal. They went away. So for modern 8-bit machines, there are people working in FPGA implementations like the Eclair 3.0. There's another group that's working on an FPGA sort of scaled down, Atari 800 XL, but it's not ready to ship yet, so I couldn't buy one. There's also native silicon hardware like the XEL 1088. Oh, really? There are people in Europe doing amazing work. There's a guy named Lotharek, whose trade name is Lotharek, who does FPGAs of all kinds of things. So I bought an Amiga 500 MIST, little box, monster FPGA, all the right kind of connectors, VGA output, USB output, and it works wonderfully. Anyway, I invite people to look up these. And modern applications. So what do people do with computers nowadays? They connect to the network a lot. So Thomas Cherry Holmes did a couple of things. A few years back, he was developing an implementation of Plato term to run on a lot of different ancient machines, and then he discovered that he needed a network connection to it. So these are things that he was displaying in 2019, Plato term on a lot of different platforms. And then he said, oh, how did they get to the internet? So he and a team of people have built little boxes that plug into various retro machines. And it's basically an ESP32 or something like it with built-in Wi-Fi, and it's got enough resources to put in web browsers and all the other things that you need. So it plugs in basically emulating serial to the Atari SIO or to the Apple II port or to the Atom computer or to the Commodore serial port, whatever. So they've been building on a lot of different machines. and it gets a lot of ancient machines onto the net with their old style graphics. So, some resources. MIT Press has published a pair of books that I like, Racing the Beam and The Future Was Here, about the Atari game machine and about the Amiga. I'm working on a book someday to fill in the gap and be the J minor trilogy on the 8-bit computers. But Jay Landino wrote a great book about the Atari 8-bit computers, which I recommend. Goldberg and the late Kurt Vendel wrote a book called Atari Incorporated, Business is Fun, which in my opinion is the definitive social history of what it was like to work there. Annotated Adventure, Robinette's eventually, if he hasn't already published it, is publishing a book about how adventure works. Steve Hugg, the guy who does 8-Bit Workshop, he's written that book specifically that explains how to write games for it. Daybreak Atari is, in my opinion, the best book about how to write games for the Atari 8-bit computer. Couple of articles that I've had work on. I worked with Ron Nicholson to write about the Amiga. I wrote this solo and I wrote this solo. There was back in 1983, IEEE Spectrum wrote an article about the design case history and highlighted the, we didn't design it to be successful, we designed it to be cheap. The programmers made it successful. If you haven't already found it, Atari's got an online museum. And I'm thinking that I'm only a minute over. So here's how to find me. Find me on Wikipedia or LinkedIn. And I didn't actually bring demos, but I'm open for questions until you run out of them. I'm assuming that the organizers will publish a PDF of these slides if they haven't already taped it. And if they publish a PDF, that means, for example, that this demo will work because I pay $100 a year to Google to have this drive. And so that's where this points to, right? For you Amiga fans out here, there you are. And you wanted me to go back here. Oh, yeah, that's the one you wanted. Okay. Questions, questions, questions. Flooding into the mind of the concerned young person today. Where can I go to get my poodle clipped in Burbank?
So what brought the decision to use the controller port from 4 to 2 in the XLs?
They weren't getting a lot of people playing these games. I mean, we actually sold the ability to do 4-player games. I mean, Video Olympics, you could buy paddle controllers and you could, a 2 and 2, and you can have 4 people playing paddle-like games. So we thought, okay, people like party games, right? So we put 4 control connectors on the 400 and 800, and our marketing people said that most players are 1 or 2 people, not 3 or 4. So in later machines, we thought of other uses for those extra bits, like controlling bank selecting and this and that and the other thing. So we went back to 2 game controllers rather than 4. And Commodore picked up the same thing on the VIC-20 and then on the C64. And Amiga picked up the same thing on all their machines, were just 2 game connectors, not 4. The marketing, we saw who we actually sold cartridges to, and the marketing wasn't saying, we need party games.
Hello?
Yes, sir.
My first computer was an Atari 800, so thank you. I do play party games with my nieces and nephews at home on consoles, so I completely disagree with marketing.
They would consider you an outlier, but that's okay. I mean, the customer is, in my opinion, supposed to be right. Keep going.
I was just curious about your opinion of the Commander 64 and some of the other modern retro computers in light of how much work you put in to make things better and faster, and they're almost going backwards.
I don't know what the Commander 64 is.
There's one on the floor. It's a Commodore 64 modern rebuild with new parts.
Okay.
But it's trying to be a better Commodore 64 makeable today.
If somebody wants it, that's great. You know, Kurt Vendel, before he died, did the FPGA equivalent of the Flashback 2. And they sold 1 million units in the 2000s. So there's money in it, and it could be fun. I haven't followed the Commodore 64 closely because I didn't work on it, and my garage and my lab are full enough as it is. You know, I offer my extra machines to my children, and they're not pack rats. They want the game machines, they don't want the computers. They say, Dad, we want you to die leaving an empty house, which I cannot promise. Questions?
Hey, Joe. So you were talking about development on the PCS.
Right?
The fact you could actually develop software on the PCS for the PCS. But there was also the Kremenko cross-compilation that was going on also at Atari. Could you
Well,
talk
we
about that?
used the Kremenko physical chassis. It wasn't, you know, Kremenko software. There was no such thing. You could buy machines that said Kremenko on them, and they're running 8080 stuff. We use them for packaging reasons, not for software at all. As soon as we got done building these machines, my little spin-off company actually built a bunch of, we took apart some 800s and built a sideboard inside with the Lindbug debug monitor and some serial ports into it. Some people may own those. I would like to buy one of those machines if I could find one. Really? Do you need it? Well, hang on to it. But yeah.
Was incomplete. I assumed it was only half of the system. I thought that Kremenko was
used as a cross-compiler, and then you just DMA transferred.
No, we actually, before we were running compilation for it on it, we were using PDP-11s and cross compilers to develop machine code. All of the code that I was aware of that was done for the Atari 8-bitters at the time was done in machine code, not in C. You know, I learned C later on and then became a fan of it later on. No, it's all assembly code. On the other hand, I have to take my hats off to the people, including the Activision founders, for doing a really nice job of architecting the Atari 8-bit computer operating system. Thomas Cherry Holmes went in, took it apart, created a new N-colon device, and hooked a network device into the operating system, and it just works. So yeah, I haven't spent a lot of time testing his stuff because I was sort of doing cancer care until a year ago. So I didn't have any time to spare, and now I'm finally at the point where I can go hang out with other nerds. More questions? Yes, sir.
Yeah, I had a question about your time at University of Washington.
I teach there now. I'm a second generation Berkeley grad, but
Right. Teaching now, do you interact with any of the research in the area for graphics or rendering or networking, and do you have any opinions on the current state of that area?
well, I don't get to do graphics research. I do have 42 years of experience in industry. I've now been teaching for 7 years, and I teach the capstone class, which is where we're trying to turn engineering students into engineers. Engineering students do what the professors tell them to do. Real engineers get really ambiguous requirements, problem statements from customers directly or indirectly. And it's their job to come up with something that does that. And the projects are all over the map. Some of my recent projects, I started chairing IEEE humanitarian conferences 8 years ago, and I learned about the UN Sustainable Development requirements, and requirement number 7 is power. Around the world, about 1.5 billion out of the 8 billion people do not have trustworthy AC power in the walls. They're off-grid. And that includes 1/3 of the population of India, which is 400 million people, right? So I collaborated with some people on developing standards for DC microgrids. And you're thinking, what the hell is a DC microgrid? People have been using 48 volts for communication since 1837 when telegraphy was invented. And the ERs around the world have not been filling up with people electrocuted by 48 volts. You can touch 48 volts. If your hands are dry, it won't kill you. 110 in the walls will. So we're developing standards for generating 48 volt power, storing it DC in 48 volts, and then 48 volt appliances. Good example. People cut down trees all the time and burn it for firewood to cook their food. This has been going on for 100,000 years. But these days, with all the people cutting down all this wood, this is not very efficient, and it makes carbon dioxide. It's bad twice. It makes carbon dioxide to make the food, and it cuts down trees which suck up carbon dioxide. But you can cook food with 10 amps at 48 volts. And every time somebody cooks food with a 48 volt cooker instead of cutting trees is a small step in saving the planet from climate catastrophe, in my opinion. So that's research that I've worked on, and my capstone students have prototyped pieces of that. Make sense? I have capstone students simulating processors and systems in FPGA, et cetera, et cetera. But that's a long story, and we should probably talk more about that later. Did I answer your question, sir? Yeah. Good.
Yeah. You said you would have liked to have slots in the 800, but for regulations it couldn't happen.
Right.
What is the story about the Amiga 1000 and the slots?
Well, the 1000 only had the ability to add double the RAM. The Amiga 2000 and 3000 had slots. And what had happened was the FCC changed the rules. Before 1979, the rules applied only to things that connected to TV antennas. And we had to be minus 60 dBm per megahertz. I'm sorry if that sounds like magical thinking, but that's basically a microvolt per megahertz. And they changed the rules in 1979, and the big change was they applied to everything, not just things that attached to TV antennas. So suddenly, the Apple II and every other personal computer was out of spec until they were designed and redesigned and redesigned until they finally were legal. And so at the time when the Amiga 2000 came out, you know, the same rules that applied to IBM PCs, which were metal box, the rules, instead of minus 60 dBm per megahertz, were minus 43 dBm per megahertz. So the radiation per megahertz was 17 dB higher. That's a lot. I don't know how many of you speak dB, but it's a lot. So it was fairly straightforward under the circumstances to build another machine that met the RFI requirements. Now, 2000, I'm working at Microsoft for communications, and they have stack ranking, which is a disease system. And it was my turn to be the scapegoat. So they told me, I find another job within Microsoft or I'm out the door. So I interviewed to be the program manager for the hardware in the Xbox. And they've got a Celeron class microprocessor, 128-bit wide double clocked 200 megahertz bus going to a GPU made by NVIDIA. And I look at that spec and I say, you know, that's going to make RF like crazy. You're going to have to put that in a Faraday cage to be able to ship it. And the problem you're going to have is, how do you get the heat out of that little confined space? I was predicting what they call the red ring of death. All three of my sons stood in line to get Xboxes, and all three of them had the red ring of death. I met a guy 10 years later in the summer of 2010 who said that at that time in history, Microsoft had spent $1.83 billion on the problem. And the fact that he knew it to 3 significant digits said he probably didn't make that number up. And that was a lot of dough. I wish they had hired me to prevent the red ring of death. Yeah, I think I didn't. I'm not sure I answered your question, but that has.
There is an exhibit about the Zorro expansion, just for the 1,000 copies.
Really?
Yeah.
I'll have to go look.
Any other questions? All right, I want to thank everybody for coming to VCF. Thank you, Joe, for coming very much.
Thank you. You can find me on Wikipedia or LinkedIn. Or
I want
I'll
to be the
here all
first.
day tomorrow, too.
I want to be the first to ask you to VCF East next year.
Okay? I was there in 2019.
Yeah,
Yeah. Which was pre-COVID.
right. So I'm getting a jump on next year.
Okay. I was approached by somebody who wants to do a VCS in Southern California. So, yeah, well, I can do this now. But I'll save it. All right, so I'm going to, unless you got more questions, I'm going to pack up, but I'm going to hang around all day tomorrow, too.